Hello everyone. Next experiment we are going to do write MATLAB coding for amplitude modulation. So today's experiment we are performing on MATLAB. Okay, so this same experiment previously we done in with the help of kit. Okay, so we have already done the how to calculate. We know already about the how to calculate the modulation index by observing the amplitude modulation wave. Okay, where there we can use function generator, CRO. Okay, and with the help of function generator and CRO, and we connect with these two with the CRO probes. Okay, so the there we can perform in the these AM wave generation with the help of these two apparatus or through with these two instruments. Okay, now this the same experiment we can perform in the MATLAB with the help of MATLAB coding. Okay, so just I will explain what is hope everyone having crack version of MATLABs in your laptops. Or okay, so while those who are not having, you can download any version of MATLAB like 2016 crack version. Also you can download anyone. Okay, latest also available, you can download from the crack version also. So now next experiment is based on the MATLAB coding for amplitude modulation. So first I have written here these, already I have typed these all coding all commands. Okay, so one by one we will check what are the commands are and what is the roles. Okay, so now first a line, that is the CLC colon comma CLC clear all and close all. Okay, so this function we are basically use basically when we are open the MATLAB. Okay, we will get the three windows, like first editor window where we can type the MATLAB code. Okay, second is the command window where we will get the all functions values. Okay, so that is the command window. And third one where we will get the output. Okay, so output window. So while save the file in the MATLAB, we have to be ensure that whether the screen is clear, okay, or editor window is clear. At the same time the command window is clear. At the same time the previous output window is also clear. Okay, so that's why we will use the CLC clear all and close all function. Okay, next first we have to be first we should know actually basically MATLAB which purpose we are using. First we should know MATLAB which mathematical laboratory purpose we are using. Okay, first we should know which purpose we are using the MATLAB. Actually any concepts which we want to mathematically prove, we required a MATLAB. Okay, or we required to mathematically, if we want to calculate any concepts, that we can use the MATLAB software. Okay, so that is the concept where we can prove our concept in a mathematically. Okay, so likewise that's why we are using the I will just the same experiment I can one more time I can brief about in the MATLAB. Okay, so second that is first we have to be imagine what is our input and what is our output. First we should know very clear. Okay, so we required what is our inputs and outputs. We are going to we are going to generate the AM wave. Okay, that is amplitude modulation wave. So while generating the amplitude modulation wave, what are the input we required? First we required the modulating signal. Okay, hope everyone understood this. Okay, second, what is our input? Okay, we required the carrier signal. Okay, and third we required what is our output. Okay, so modulating amplitude we required, carrier signal we required. Okay, at the same time carrier frequency we required and modulating frequency we required. There are four different inputs we have. First we have to be assume. Okay, then we can perform the then we will get the output of amplitude modulation. Okay, that is AM wave generation. Okay, so one by one, for all the inputs and outputs. There are 4 inputs, and modulating amplitude, carrier amplitude we required, modulating frequency and carrier frequency. These 4 inputs we required the time period, as well as we required the in output also we required the time period. So in the second line we have to be set the command like t equal to time period, we have to be set from 0 to 1. Okay, here 0 colon 0.001 and 1. Okay, so basically we can assume here the time period from t equal to 1. Okay, t equal to 0 to 1 we assume, and the subdivision of time period we can put into a 0.001. Okay, understood? Time period t equal to 0 to 1, and from 0 to 1 we the total time period. Okay, and the subdivision of time period we can assume as a 0.001. Okay, another thing is, now we can assume these are the 4 inputs where we can put into the single inverted comma. Okay, so V suffix m we can assume input of modulating amplitude, B suffix c input of carrier amplitude, F suffix m we can assume input of modulating frequency. Okay, and F suffix c that is input of carrier frequency. Okay, in single inverted comma whatever you want to put, that it should be visible in while we can run the program. Okay, so I will put modulating amplitude equivalent to, that value we have to be put, carrier amplitude equal to. Okay, then we have to be put the amplitude frequency equal to, and then carrier frequency equal to. Okay, so likewise we have to be put the all input values. These are the 4 input values we have to be given one by one. Okay, now we are putting one formula here for capital A, that is capital A is A, that is one input capital A equivalent to that is our total A equal to, we have to put one value, that is V suffix m into sine of 2 star pi pi, that is the pi value we can put as it is the final value, or you can put as a pi also, the pi star f suffix m star t. Okay, now this is the formula we have to be inserted here. Okay, that formula that is the v suffix m, that is modulating amplitude into sine of 2 star pi star f suffix m, that is modulating frequency, and star suffix t, time period t. Okay, so now we know this is our first input signal we are going to generate. That means we are going to generate the modulating signal. So modulating signal we can assume capital A equal to Vm star sine of 2 star pi star Fm star f suffix m star t. Okay, now this output, actually we will, how many inputs are there, how many outputs are there, first we should know. Okay, and in each inputs how many inputs we are going to generate and how many outputs we are going to generate. Actually first we are going to generate the modulating signal. So first output is modulating signal, second output we are going to generate the carrier signal. Okay, that is our second output, and third we are going to generate the amplitude modulation, that is AM wave. Okay, so likewise 3 output we required, that means 3 output, that means 3 different figures are there. Okay, so that 3 different figures how we can plot in a single command window. So that's regarding we required a subplot command. Okay, that is subplot of 3, 1, 1 I mentioned here, that means subplot command of m, n, p. Okay, so subplot m is mentioned as a row, n is mentioned as a column, and p is mentioned as a position. Okay, so subplot command of okay, so subplot of m, n, p. Okay, that is the one concept. Now the plot command, that is t, a. Okay, so plot command of t, a, we required to plot which plot of x, y, that is the natural command, plot of x, y. That means plot of x, y, that is plot x axis we can put as a t, and y axis we can put as a capital A. Okay, now we are going to generate that another output, that is we can put as a this output we can title as a modulating signal. That is our first input signal, or that is our first input that is our first output we are going to generate as a figure. Okay, then second is that is we can put as a title modulating signal. Then we are going to put the b equal to v suffix c star sine of 2 star pi star f suffix c star t. Okay, so we can put the command again for this we can put the formula. Okay, then we know the value of Vc, we will put the Vc value, we can put the Fc value, and t value already from 0 to 1 subdivision of 0.001. Okay, now we can put the again same, this is our carrier carrier signal. So carrier signal again we have to put the another subplot command, subplot of m comma n comma p, where subplot m is the row. So total 3 row we have to be push. Okay, and total 1 is the row, 1 is the column. Okay, so row comma column comma position, we total 3 rows are there, single column is there, and second position we will put the carrier signal. Okay, that's why we can put as 2 here. Okay, remember, so subplot of m comma n comma p. Now we can put the plot command. Plot command, that means x-axis which value will be there, and y-axis which value will be there. So plot of t comma b. So plot of t comma b, t, that is x-axis time period, y-axis we can plot the total value of b, that is the our carrier signal. Okay, total final carrier signal. So now the plot of t comma b, it's we can put the title, that is the carrier signal. Okay, that is the carrier signal. Okay, we can as a titled. Okay, and title we can put into a single inverted comma in MATLAB. Okay, now we can put the m value, m equal to our for amplitude modulation generation, we know modulation index is given by v suffix m divided by vc. So that same formula we can put m equal to v suffix m divided by vc. V suffix m equal to, that is a modulation index. Okay, so I will not explain once again the whole experiment, just what are the commands we are using the MATLAB. Okay, now c. Okay, so it's another output, another variable we can that is our total amplitude modulation, or we can say that is our total amplitude modulation generation. So c equal to the formula of v suffix c, that means v suffix c value. Okay, as it is that is complete a value we can put into a value plus m dot b value. Okay, that is Vc divided by 2 star sine. This complete formula we have to be put for the amplitude modulation wave generation. Okay, based on this formula we will get the final output of that is based on the amplitude modulation. Okay, now third output or third figure we will plot into a subplot command of 3 comma 1 comma 3. Initially we will put subplot of 3 comma 1 comma 1, then we can put the subplot of 3 comma 1 comma 2, then we can put the subplot of 3 comma 1 comma 3. Okay, now we want to plot the output. Okay, so plot the output in versus t comma c. Okay, so plot command x comma y, that is the normal command in the MATLAB we are using. So plot of t comma c, that means t is x-axis, c is the y-axis. Okay, so y-axis this value will come. Okay, and in y-axis c value will this like. Okay, and in x-axis we can put the t. Okay, that is on the value. Okay, now the title we can put as the amplitude modulation. Okay, so it's a very simple experiment based on how we can generate the amplitude modulation into the MATLAB. Now I can put the run command. After that I will we will get the final amplitude modulation output one by one. Okay, so now you just check now the waveform. Now we can put the first amplitude, we have to be put the first modulating amplitude. We can put the amplitude 10 volt. Okay, amplitude modulating amplitude we can put 10 volt. Then carrier amplitude, carrier amplitude we can put as a 5 volt only. Okay, then we can put the modulating frequency, so 5 hertz. okay, 5 hertz we can put, okay. Then we can put the carrier frequency. Carrier frequency we required a more little bit higher, so we can up to put the 30 hertz, okay. Now you can enter, and now you can check the final output value, okay. So now you can observe this is our final output, okay. Now this final output we will observe the subplot command. Why we are using? Because we want to modulating signal into the first position, that is the modulating signal. Then we required in the second position carrier signal, and the third position we required the amplitude modulation. So it is approximate of amplitude modulation waveform like, okay, and that it's visible in the screen, modulating signal, then carrier signal, then amplitude modulation, okay. So now we can easily calculate the V max value, okay. We can calculate the V minimum value, okay. Again we can calculate the V max value from this, okay. So likewise we can calculate the easily calculate the amplitude modulation generation, okay. Hope everyone understood this. Thank you.